Antonio,
¿Qué pasa?
¿cómo te gusta?
Now you're live.
Microphone.
We are live.
Yeah, ready. Okay. So good afternoon, everyone. Thanks for being here. Today, we are talking about transport and how AI will support transport. My name is Alessandro Tricamo, partner with Oliver Wyman, and we'll discuss this with three experts. Dr. Antonio Gera is with us. Dr. Antonio is the COO of Libellum, and is also the technical coordinator for the local digital twin toolbox, which is the largest AI initiatives on urban environment from the European Union. We have with us Enrique Gomiche-Murcia. Hope I pronounced it correctly.
Correct.
Enrique has 20 years of experience in product development. He's currently the director of products for SCAI, here based in Riyadh, and is focusing on product and people-centric products using AI. And then with Dr. Swaib Khan. Dr. Swaib, professor of computer science for the last 15 years, recently moved to the private sector, co-founder and CEO of Hazen AI, a startup based here in Saudi Arabia, in Mecca, focusing on computer vision and data analytics for transport and traffic management. Maybe, hello to everyone. So maybe let me start with a common question for everyone. No? So the AI is obviously a very hot topic in transportation. AI model and simulation models are becoming an increasing part of transport and urban planning. No, however, there are problems specifically with data quality, data availability that are needed to feed these models. Maybe starting with Dr. Antonio, where you see the main challenges today and the gaps that we need to fill?
So right now, for us, the main challenge and opportunities is to identify the type of cars and also being able to identify properly what is the impact of every type of car in the general pollution and also in the general congestion. So today, what we are doing and the kind of innovation we are addressing is to have really the capacity not to only identify the quantity of traffic that is quite already developed, is to also identify the type of car, because the kind of congestion from a truck or from a bus is not at all the same kind of congestion or difficulties that can be created by other kind of vehicles. So today for us it's very clear to go at a next level of capacity to identify the type of vehicle, the first point. And the second point, I will say that is also the correlation of the traffic with all the information related, for example, pollution, noise, just to guarantee that we understand exactly what is the level of impact of the traffic with the environmental pollution. Just to give you an example, on average in Europe, it's 22.5% of the pollution are coming from traffic. 22.5%, no more. So it's very important to identify, based on these numbers, exactly where is the type of traffic much more influencing, and also try to understand what are the potential benefits when we increase or we integrate some new improvement, what is really the consequence and what is the real benefit.
Adding to what Dr. Antonio mentioned, we have to gather all this data. There is a lack of sensors that currently we are trying to solve using computer vision, that it will give us an advantage, and the integration of the agents that are in a traffic, because you should see traffic as a complex system. Okay, there are a lot of agents that they work individually. As humans, we drive. Even we share the ways, each one have a different goal. And there is still, that's why we are trying to map in the unseen, because there is still the gap to gather all the information where we want to go, to have a proper planning for each one and reduce the congestion on the streets.
Dr. Soib?
Yeah, just to add to that, I think one of the key challenges in simulation has been that the traditional simulation of traffic systems is very much an ab initio model. So in software packages, people have been doing like car following model or lane changing model and trying to model traffic as a set of rules. But humans are very complex. Traffic complexity across the world is very different. We have all seen videos from, let's say, India or Vietnam of how chaotic that traffic feels to us. But that traffic has its rules. It's just that the rules are not as simple as you change a lane when the lane acceptance gap is long. The fact that that traffic has rules is borne by the evidence that people don't randomly crash into each other, right? So the driver in that traffic knows what's going around and how other people will behave. But that's too complex to model with a set of simple rules. And to be able to model that, the challenge is the quality and the fidelity of data. It's not just count of vehicles, it's the subtle behavior in traffic, how traffic even changes from one city to another. So that gap is very large, I think, right now.
And Dr. Soib, maybe just remaining with you, real-time solutions are obviously increasingly the target, how to react on problems with live-time solutions. However, the models that simulate these type of solutions and then that they are used to adopt this type of solution require a large amount of information and data, which is not always available. What could be some of the solution to bypass this problem and increase the adoption of this type of solution?
I think that's a very good question, and I think that is the crucial question right now in the traffic industry, because like I said, people worked with rule-based models before, but AI or our perceptual understanding is not like that. Let's say, take example of face recognition. When I meet you, I recognize you. If somebody were to ask me, write the rules of how you recognize Antonio, you can't do that, right? Because it's actually a very complex process. So what has happened with AI is that the data-driven approaches have come out. Now, traffic data has its limitations right now. The traditional ways are very expensive. You dig road to install a loop sensor. Radar technology and so on are very expensive to deploy. At least half the world has not benefited from that at all, right? These technologies have been very much in the Western context of traffic. And the challenges are immense in doing that. So I think that's the other level. There is a simulation level of AI, but it's actually the sensing level that has to rapidly deploy AI and get the fidelity and the richness of data that can feed the simulations in a data-driven way. So that's the Gen AI for traffic simulation concept. Yeah.
And Dr. Antonio, we talk about quantity if we want, but we also know that the quantity is not the only part of the equation. So quality of data is as critical as the availability of the information. And more often than not, the quality of the information we receive to feed and train these models is not of the right quality. So where you see the challenges today and potentially where we're going?
In my opinion, today there is a big challenge regarding all the but at the same time there's a lot of opportunities regarding the reuse of existing data from traffic control and traffic management. As I mentioned, you have sometimes data that is relevant to count number of cars. You can know also, for example, the average length of queues or average time, but you don't have exactly other kind of data that give you the right accuracy and quality. So for me, the opportunities are all related to data fusion, where we can get all the classical system to counting car or monitoring traffic or estimating traffic that are very accurate, but they don't give you enough information. Computer vision gives you a huge amount of information, but you will have a lot of challenge in order of getting the same level of reliability. And then, of course, there is a new level of emerging technologies like radars, like also identification of radio frequency information coming from the car. So for me, the future and the opportunity is getting data quality based on data fusion, where we can start from the legacy system, integrating computer vision like the big connector, and extend it with new IoT technology where Libelium is working, like radar and other emerging technologies to complement to the computer vision lack of sometimes of relevant accuracy. So for me, based on that, as my position as the chairman in IEEE for data quality standard, our expertise is guaranteed that we offer the right tools to classify and identify every sensor, real accuracy, and real reliability, and of course, the opportunities that when we create an standard that tell you exactly what is the level of data quality and level of error, like epsilon, but how many epsilons you have of error, we transfer that information to the AI model. So the AI model will be aware about how reliable or trustable is a data source, so they will guarantee that in the final classification of decision making, they will take this context data, but they will not influence as much as possible this information of final decision based on this potential biased data.
Thank you. And Enrique, now obviously with the right amount of data and the good quality of the information, it opens the door to the potential application of simulation, AI-powered solution, and so on. Where you see the benefit today of AI-powered solution and option on urban planning, on transport planning?
Okay, basically, what we have implemented in Sky, you can pass and check our booth. We have a smart motion platform that it's smart traffic management. When you using computer vision models and different other sensors, we can allow, for example, municipality of Riyadh to, when there is an event like now, to predict the traffic that is going to happen and prevent. You have, nowadays, you will see sometimes in Riyadh, they crowd one street because this is already managed. There is some prediction that tell that this street is going to be crowded, then the traffic should go through the other one. If there is a need for a VIP, they will open a channel. There is now something on development that there are even smart fences that they move automatically with the need of the police going on. Then this will provide extra quality of life, that at the end is what we are looking for. We want all this technology to support of life and make it better. The final solution will be autonomous driving, okay, but we are a little bit from for that. Then we need to deal with all the information and be able to predict the patterns, because when you live in a city, you know the street that you need to avoid. This is what the machine is going to help us to understand where are the patterns, where you need to focus, and when you need to work and release some traffic.
And if you live in Riyadh, you certainly know that this is
the
final target now.
It's our target. Actually, for the previous event, the traffic was reduced 10% from the leap, from one leap to another leap, using this kind of technology.
So we hope that the technology will adopt broadly in the city so that we can get faster where we need to go. Dr. Antonio, so we talk about digital solution and the digital space and AI in transport and urban planning. Part of this space is certainly what you are working on in terms of digital twins. So how you see the use and adoption of digital twins in urban planning and in transport planning solution?
So thank you so much. So at the end of the day, always mention, we are doing in Riyadh, we are doing in capital cities. I'm working with cities like Barcelona, Valencia, and several capital cities in Europe. But of course, when you are addressing traffic challenge, must be deployed widely, not only in capital cities. And the digital twin has two key values. One is that help us to make the right investment, to identify via simulation what are the real benefits and opportunities to reduce risks and predict better what are the benefits, but also has a second clear benefit, that is replicability. Is that when you are learning from an experience in a city like Riyadh, you can scale or don't scale, because you have smaller cities, this experience, this investment to other cities. And that is what we are doing right now in European Commission. For example, for low emission zone, we started with the city of Madrid. We follow up with other cities like Tarragona, Marbella, and finally cities like Cartagena took benefit of all these others' experience to make the decision and investment plan. So this replicability and this capacity to scale models, to adapt models to different scales, and to learn from previous experience is amazing to guarantee that, for example, when we go to a smart nation, because not only a smart city of Riyadh, we go to a smart nation in Saudi Arabia, we can easily replicate and scale up, and that is what European Union is looking for, developing what is called local digital twin toolbox. Create a local digital twin for every city, for every department, based on all the experience from all the other cities that are the flagship.
Thank you, Dr. Antonio. And Enrique, the planning is obviously an important part, to get the right solution, and digital twins will help us getting there. At the same time, and specifically for public transportation, reliability is key. If I want to go somewhere, I want to know that I will get there at some point without the level of uncertainty that sometimes today public transportation implies. How AI can help us, and how we are moving in a more reliable public transport ecosystem?
What actually is going on related to public transportation, it's we are using mobility as a service to provide for the citizen a complete solution. Like if now we have metro and we have bus in Riyadh, but reaching the metro, it can be difficult. Then with this amount of data, it will be able to provide you the proper combination of information that you need to reach the metro. Maybe first you need to get a scooter or a small shuttle, reach the main station, and after you get a bus, everything should be automated. And the benefit that, for example, the bus lines or the metro are going to get, it's like they will be able to predict how many people is using this line. Then they will be able to give more resources there, more buses to this neighborhood, more capacity for the metro to the other line, also to do predictive maintenance, because you will be able to understand the utilization of each one of the services. And the final goal, again, will be to provide to the citizen a good experience. Then also inside of these places, they are smart spaces. You have Wi-Fi in the metro, you have Wi-Fi in the bus. Then we will be able to gather some information to do some future urban planning related things.
Thanks. And Dr. Sohaib, maybe just to close our short session, we discussed about challenges, we discussed about possible solutions and how some of these applications can help moving forward on traffic, transport planning, traffic management, congestion solution. Where do you see moving next? So what will happen next? What are the trends? How we can get there? And specifically, what is happening here in Saudi Arabia? There is a high vibe around digital and AI.
Yeah, our vision, how we see the future evolving, I think two key predictions that I can make. One, that cameras are going to play a much bigger role in traffic sensing than what they are doing right now. In fact, it looks like there is almost a possibility of converting any commodity CCTV camera into a sophisticated traffic sensor if you have the right software ingredients. The software is not quite there yet. There are still gaps. Some technology we are developing in our company, Hazen.ai, is about 3D sensing from a single camera so that it gives you the similar or better quality data than what a traffic radar gives you from a commodity camera. So that, I think, is one major prediction that I have. The second is, in seeding these models, we are going to see a lot of synthetic data also being used for seeding the computer vision models that are going to actually then lead to Gen AI simulations. So I think synthetic data in future is going to play a very major role, because that's a bottleneck right now in deploying computer vision systems at scale. You asked about what's happening in Saudi Arabia. I think there is a lot of very interesting things happening in the traffic space. We have very determined support to change the outlook of how traffic is viewed here. There have been a lot of improvements in that. Entities like Sadaya, for example, their Sawahir platform is doing a lot of different analytics right now, using the paradigm that cameras are going to play a major role. So I think even in Saudi Arabia, we are seeing the camera deployments scale up and their traffic users scale up in a very comprehensive way. And we are seeing a lot of commitment and a lot of support of all the entities behind that vision to kind of really upgrade the safety of road users.
Perfect. Thank you. So thanks, everyone. This closes a bit our short session. Thanks to Dr. Antonio, Enrique, Dr. Soib for being with us. Thanks, everyone, for listening to us, and hopefully it was informative.